Welcome to the last session on operator overloading. So far we have looked at the need for overloading operators, how it is supported in C++ for basic operators, and then yesterday we had an in-depth discussion on how to overload left shift and right shift operators for C in and C out. So we were towards the end we were thinking about overloading the new and delete operators, and we briefly discussed about the need for such a processing. For example, different memory management system. So you are not happy with the existing mechanism and you want to have your own memory allocator. In such cases you can define your own new method, right. So I am on slide 23, and so what we said is that new can be overloaded if you want to have your own user defined or custom allocation, and some of the examples are, for example, you might want to reuse the memory of the deleted nodes, not that the existing C++ delete and C's free mechanism, it does not use the memory of the deleted nodes, but maybe you want to do it differently. You don't want to really reclaim it at that time, but you want to reuse that memory maybe later, keep it getting allocated and so on, right. Alternatively, if you want to do garbage collection, which happens in, for example, Java, whenever there is a managed runtime, in such cases you want to define your own garbage collection. In such cases, defining your own memory allocator is quite useful, and in some cases there might be other optimizations which you might want to perform, for example, for improved locality, right. So when we are allocating memory using malloc or new, we don't know where that memory is coming from, where that is getting allocated, but if you know that your application requires that, or it gets benefited if those multiple memory allocation requests happen contiguously in memory, because maybe later you want to process all of them together. Let's say about adjacency list of a graph, for example. So in general the adjacency lists can have varied lengths and you might allocate them separately, in which case they will be interspersed in memory. However, if you can concatenate all of the adjacency lists together, you might be able to kind of copy the whole graph from one place to another quite easily. So in such cases, improved locality might be another optimization that you want to perform by using an alternate memory allocation mechanism. And usually if you are allocating new, then you usually also require overloading new also requires overloading delete, because you are changing the existing functionality of new. So therefore correspondingly typically you require changing the functionality of delete. So we have an example here on slide number 24, and in the interest of some, I'll probably write down important aspects of this code on the board. So the main looks like this. Where there is a type A and I am defining a pointer to that type. And why do I need a pointer now? Because I am talking about new, right. So new returns a pointer. I am going to say new A, and in case you have certain parameters to be passed to the constructor, you can do that here. Alternatively, in our case we don't have any arguments to the constructor, right. So there is a default constructor that we are using, and then A arrow set data. There is some member function that we are using, which is assigning some value 3 to some one of the members of this class, and then I am printing something and then returning 0. So the important aspect of this code is that I am defining a pointer to A type using new, and A arrow set data, some member functions of that I am calling set data, get data, and so on, right. This code remains exactly the same as it was when you had overloaded the operator new or not overloaded the operator new, right. So what this means is that you are going to use exactly the same mechanism for operator overloading. So let us write down the operator code here. So when I am saying there is a class A with that operator being, so that operator I should be able to invoke from main, and therefore that needs to be public. So apart from the get data, set data methods, there is going to be an operator new. What should it return? Well, it should return pointer to A, right. In general, you can talk about returning white star or you can return pointer to A, either way should be okay. And then there is a size t parameter which needs to be specified. The argument that we pass to new, that is the number of bytes you want to allocate for that memory, right. And then I can have a cout here where I say that in new, and what I do essentially is, in this case I am just calling malloc, and whatever is its pointer I am just returning that, right. So this is just a very rudimentary allocation just to allow us to understand the syntax of overloading new, and the code essentially remains the same as far as main is concerned. Only in case of the operator overloading, we use the syntax very similar to what we have been doing. Instead of that particular operator, let's say plus or left shift and so on, we are going to use new as the operator with the size as the parameter, and then whatever is the functionality which you want inside, that is going to, that you can use. However, if we are using new such that it returns a pointer to a type, well, the similar thing you can use. For that you have to make sure that the return value of that operator has to be of that type, right. So in this case white star is convertible to any other star, and therefore we are using white star, but you can use a star also, it is not really a problem. Alright, so this is the basic syntax of overloading the new operator, and if I want to, well, get into the delete, right. So before this, which is usually a good practice because we have changed the meaning of new, I might want to change the meaning of delete. So I want to delete A here. Delete also requires a pointer, and then if I want to implement that delete here, I am going to again, so delete is not going to really return anything, so it returns void and then operator delete, which is going to require essentially a pointer to what we are trying to delete. So void star pointer, and inside that, since I am using malloc for allocating, I should use free for deallocating. So again I can say free ptr, and then here I can just print I am in delete, just to, for our debugging purposes, that this is what is the sequence that is happening. For example, if you do not have this delete function, it is not that this memory is going to get deallocated automatically, right. So the free will not, that in delete will not get invoked, right. Alternatively, if this would have been, in some cases, if you are for example, the constructor and destructor is not going to be automatically called. If you, so for example, destructor will not be automatically called if you have it as a pointer. However, if you have it as a regular variable, non-pointer, scalar variable, then the destructor will get automatically called, because this allocation was happening on the stack, right. So if you have, for example, A, B, right, this is a variable of type A, and if A is a class, then B is going to get allocated on stack. So this is on stack, whereas this is likely to be in heap. And why I am saying likely to be on heap, because it depends upon how the implementation of new is. The default new will always allocate it on heap. So when it is on heap, it is not necessary that the destructor is going to get called at the end of, when the scope finishes of that function, in this case main. However, as far as stack variables are concerned, the scope, as soon as the scope finishes, at that time the destructor is going to get automatically called, right. So that you can check just by executing that program. Alright, so this is the basic syntax of overloading new and delete, and if there are any questions, please ask those in the question tab. Otherwise we will move on to overloading the subscript operator. So let me just quickly check if there are any. So today's plan is, as I was mentioning yesterday, is that we will discuss about the rest of the operators that we want to overload, let's say in the first 1 hour, and then in the second 1 hour we can take more questions, plus I would like to discuss a few questions from the quiz that we have designed and discuss about overloading the subscript operation. So there is a large piece of code given on slide number 26, but essentially that is I mean, don't get bogged down by that large piece of code. It's just that that's sometimes required for explaining a larger piece of explaining some concept. So let's change main. So what we have is a class students, right? I mean, class meaning this is a C++ class that I am talking about, which probably is talking about students maybe in a class, let's say CS17, right? And then what I have is some syntax CS17 plus 2 and then CS17 plus 1 and then CS17 plus 3, CS17 plus 4 and CS17 plus 7 plus 6. So there is a chaining happening here, plus 9. So I have deliberately made it not really in that order, so it becomes easier for us to understand the code when it executes, right? And then I have commented out the print, and then I am saying that std : cout CS17 of 6, right? So what we have is there is a class students, this is an object of that type CS17, and then I have an operator plus which is defined on CS17, that is on students class, which is adding, let's say 2, 1, 3, let's say these are just some student roll numbers which I am adding, right? And then I can have a cascaded application of this overloaded operator plus, in which case I can add multiple such students in the same line. And towards the end what I want to print is CS17 of 6. Now note that CS17 is not an array, right? CS17 is an object of type students, and this operator, subscript operator, as we know of, is actually specified for arrays, which means that I need to overload this operator such that I will be able to perform such an operation. This is a very interesting use case of that CS17 is defining an aggregate, an object of a particular class is defining an aggregate, and that aggregate you can index using certain key. In this case the key is numeric, but that need not be the case. You can have a roll number as a key, for example, which is likely to be a string, or you can have, let's say, Aadhaar card number as an index, and you can identify a person using that. So in all of these cases you are likely to require this subscript operator to be overloaded, right? So this, in this case it is integer, it could be arbitrary type and so on. So let's see how do we overload these. So as far as plus operator is concerned, that I suppose you will be able to do easily with our previous knowledge of overloading operators. So let's try that. Okay, so let's say that there is an operator plus, what does it take and what does it return, right? So all of these students that I am adding, let's say these are different roll numbers that I am adding, these need to be added to some data structure, right, so that the state is maintained, all of this information is maintained. For this I will require a private variable, which essentially in this case will be a vector. So I can possibly keep track of std : vector of something, and let's say that is names or roll numbers, whatever you want to call it. So what are those names? Since I am adding all these as strings, I can have it as vector of strings, and accordingly I will need hash includes here, where I can include hash include vector and hash include string and IO stream and so on, right, that I will skip. So now this is a private variable, so so that I am careful about, but what I am going to do in plus is that I am going to pass that as an argument. So how do I pass that as an argument? Well, this is of type string, let us say x, and I need to add that x to names. So I can do names dot, so there is a function push underscore back in vectors which you can use to push that particular element to the end of the vector, right, which means that after all of these plus operations, names is going to contain all of these in this particular sequence, right, that sequence is also important. But then there is something which we missed, right. So as far as these are concerned, this is okay, this is okay, this is okay, this is okay, but as far as this is concerned, well, it is returning nothing, so I cannot really add plus as a cascaded operation, which means that I need to return something such that I will be able to add it to it again. So in this case what I want is that I can apply plus operator on a variable like CH-17, which means that it should be of type students. So when I apply this, when I want to apply this plus operator, I should be able to return via this operator application a variable of type students, in this case essentially CH-17 itself, and therefore I can do something like, how do I return that? Well, you can do star this, right, this is a pointer which is pointing to the current object, a dereference of that I can return. So what should I write here as the return type? Well, this pointer is pointing to a star, so star of this is going to be a, and if I write a here, will that be correct, right? So that is okay, so I think I made a mistake, this is not class A, sorry, this should be student. This we copied from the previous example, so we forgot to change that A to students because this is of type students, right. Alright, so this is returning students, is that sufficient? That is my question, right. So if you carefully look at the slide, you will realize that what we want really is that CH-17 is exactly the same object to which all of these 6, 9, 8 should get added, it should not be a copy. Now what will happen with this code is that CH-17 plus 7 will add it to CH-17 and it will return star this, which will be a copy of CH-17. To that copy we will add 6, which will return another copy of that copy, first copy, to which we will add 9 to the second copy, and it will return third copy, to which we will add 8. As far as CH-17 is concerned, you have added 2, 1, 3, 4 as well as 7, that is it, all of these others are missing. In fact, if you have added only these and you try to do CH-17 of 6, you might get a seg fault because that index does not exist, there are only 5 elements that you have added, not 7. So the problem here is that we have missed this ampersand, we need to send a reference to CH-17 so that you will be able to apply all of this together. Alright, so that part is about operator plus. Let us define the operator. So in this case, as I have done in the example, it is possible that you might have to do another operator overloading with this part changing to char star or const char star, and that can happen because there may not be any direct conversion from string, sorry, the char star to string, so you might have to re-implement the operator using const char star. So that I will skip, that is easy, you can see that later. But let us focus on the subscript operator, that is the main part that we want to talk about. And this subscript operation should take what? Since it is inside the class, it takes just one parameter which is of type integer index, and it should return what? It should return the 7th element, this CH-17 of 6, so it should return 7th element of what we have added. And what is that element type? Well, we have said that these are all strings, so it should return a string. And I should say operator subscript. Right? All right. So, and what should it, how should that be implemented? Well, what you need to do is to translate that subscription which was on the object to an element inside the object. And what is that element? That element is names, which is of type vector. Is subscript operator defined for vectors? Yes. By the way, vector itself is not really an array. Vector is also an object type. I mean, it's also a class, and that subscript we can apply. For example, return names of index. This itself is an overloaded function, right? So subscript operator is overloaded for names which is not an array, it's an object of class vector. And since you are able to apply that index, so for example this is one example where you can see that the templates and the operator overloading is happening together. Alright, so this subscript operator is going to get translated from student's subscription to vector subscription, which internally in the implementation of the subscript operator inside vector is going to implement it as array of index, right, because inside the vector the elements are also stored as arrays. Alright, so this part seems to be okay. So far so good. What we require now is whether this works. Okay, so there is a question that I have asked, and let's see what it does. So CH-29 of 6, this is going to invoke this operator which is going to return names of index, right. So what we are asking is whether this is going to print, so this is 0, 1, 2, 3, 4, 5, 6, right. So we are expecting that it should print 9 as the answer. Whether that is what is getting printed, that is something which we are asking. So in case you have any thoughts on that, please to slide number 27, right. So what's happening now is that so now we have changed the main code to a little bit different. So what we are saying is that, okay, so that should expect us to print 0, 1, 2, 3, 4, 5, 6, so it should print 9. So that part is fine, right. So now we are talking about what is the problem with this code. As far as expectation is concerned, yes, it is printing 9, that is okay, but there is some more problematic part, and that for understanding what that problem is with our code, we will have to add another statement. So what we do here is CH-29 of 6 equal to, let us say I write in capitals, capital 9, right, that is something which I want to print, and then I again do the same std cout CH-29 of. So logically, by looking at this code, what we feel is that I should be able to print small case 9 here, right, that is what I have done. Then when I set it to capital NINE, after that when I print, I should get again capital NINE rather than small NINE, right. So that is what we expect this code to do just by looking at the program. However, again let us go back to our discussion and say that what you see is what you get when you have operator overloading. Some things are magically happening and we do not understand sometimes what is really happening unless we get inside the implementation. So if you try to execute this code as it is, what you will realize is that the output, so this prints 9, that is correct. However, this also prints 9, which is not what we wanted. What we said is the CH-29 of 6 should be capital 9, whereas it is printing small case 9. So the changes are somehow not getting affected inside this one. So why is that happening? That is something which I would like you to point out. The reason why this is happening is because when we are talking about CH-29 of 6, are we really referring to the L value? What we are referring to is actually an R value, well not R value but let me put it this way, R value we do not expect it to change. What we are talking about is a copy of the string, right? We are not really changing. So when we expect CS17 of 6, we expect it to change names of 6, right? We do not expect it to change a copy of names of 6, and if that is the case, the operator that we have defined, what it is returning is names of index, that is okay, but since it is returning std : string, it is returning a copy of that particular string, the 7th element, and that 7th element's copy is going to get assigned the value NINE. As far as names of index is concerned, names of 6 is concerned, that is still containing the previous value, which was this 9, and therefore when we try to print CS17 of 6, it is still going to print small NINE. So how do you fix this problem? Well, we just need to insert ampersand here. This pass return value by reference. So what you are returning is actually a reference to names of index, and this is a very peculiar case because when we are talking about this subscript operator CS17 of 6, that can be used both as the R value as well as the L value. You can use it as the value of CS17 of 6. Similarly, you can use it as the left hand side for the assignment statement. So in case of arrays, for example, we can say something equal to A of I. Similarly, we can use A of I equal to something, right? So it can be used both as R value as well as L value, and that we should be a little careful about when we are overloading the operator subscript. So that is one important aspect which I wanted to convey. Now when you have this ampersand, at this stage we are not really changing the copy, we are actually changing names of 6, and therefore this prints NINE as expected. Now what you see is what you get, right? So this should be kept in mind while overloading the subscript operator. Alright, so we will continue our discussion further. Yeah, so that is what I have on slide number 28, where I have highlighted that operator subscript should return a reference to the string std : string rather than a copy of it. Alright, so we will move ahead and we will talk about probably the last part of this discussion, primarily about the smart pointers. So why do we really require smart pointers? Well, what happens is that we all know that people who use pointers, they always get bogged down by the kind of pointer errors or the memory errors that we have. For example, we usually get these segmentation faults in Linux because with pointers you have issues like null pointer dereference or dangling pointers and so on. So when we do, for example, p equal to malloc, right? So null pointer dereference essentially is going to say that if I have p equal to null, and then somewhere down the line I am doing star p somewhere, right? So I am dereferencing a pointer which is already null, right? It need not be directly p equal to null, it could be p equal to q and that q is null, or p equal to malloc and the malloc failed and therefore it returned null, and so on. So in such cases what I get is a null pointer dereference, and which is disallowed, and therefore you are going to get this exception. Similarly, in case of dangling pointers, let us say I have p equal to malloc, and then somewhere down the line I freed that memory and then I am dereferencing the pointer, right? In such cases what you get is a dangling pointer. So for example, free p is not really going to change p to null, right? In case of C, for example, free p is not going to change the value of p, and therefore p was whatever it was pointing to. Let us say after malloc, p was pointing to some memory area. After free, I have removed this memory area, I have deallocated this memory area. However, p is still pointing to it, which means that p's value is still the address of this memory, which is no longer allocated, and therefore when you do dereference, you are actually referring to a wrong pointer. So therefore this becomes a dangling pointer. So these issues are rampant when you have lots of pointer usage, and if you are not careful, or because of the complexity of the application, such problems might occur, and therefore we might get into issues with respect to memory allocation and deallocation. There are issues that occur, for example dangling pointer, as we were discussing, the shallow and deep copying. So imagine you have a class or a structure such that it has, let us say, some integer, and then there is a pointer also, right. So let us say there are some class A, and then there are two objects O1 and O2 of this type, alright. And what we do is that O1 dot P equal to malloc, some 10 and so on, right. That is what I did by allocating this memory. So what is happening is that O1 dot P is actually pointing to some memory location. Now if I do O2 equal to O1, that is going to create byte wise memory copy of all of this, which means that the value of A is going to get O2 dot A will contain the value of O1 dot A, and similarly O2 dot P is going to contain, so this is O2 which has two elements, and this is O1 which has two elements, and when you do byte wise copying, let us say that O1 dot A was 5, this value will be 5, so this value is 5, therefore this value becomes 5, and let us say this memory location is 1000, so that memory location 1000 is going to get copied here. What this indicates is that this particular pointer O2 dot P is also pointing to the same memory location. This is shallow copy. Now let us say that I do, now these two are kind of, we visually or logically when we look at the program, we feel that these two are different objects. What I have created is a copy. So when I do free O2 dot P, that should not affect O1 dot P, right. This is something which we might think about. However, that is not the case. You have deallocated this memory area, O2 dot P is pointing here, O1 dot P is also pointing here. So although you can take care of O2 dot P is null, what you already have is O1 dot P has become a dangling pointer, right. So what you had created as a copy, that is not really going to serve your purpose. What you should have created is a copy of this memory area such that O2 dot P is now pointing to the new memory area, so that when you delete this or free this memory area, the other memory area still remains and no dangling pointer gets created. So that is a deep copying. However, in such cases there is a possibility that you might create dangling pointers in such a manner. So to avoid some of these cases when you have allocation happening but you forget to do free, right. So sometimes that can cause issues. If you have allocated something and forgot to do the free, then you are essentially creating lots of memory, and especially if it is inside a loop, then you might end up creating lots of garbage, because that memory area. So when you allocate, for example, let us say this is some memory area which is allocated. This memory area is useful provided it is being pointed to by some pointers. Then only you will be able to refer to this area, especially the one that you have done with malloc or new. If there are no such pointers, if you lose these pointers, then this memory area exists as allocated, but you are not able to refer to it because you have lost track of it, you have lost pointer to it. This has become a garbage. This can be detrimental to performance because maybe this memory area you could have utilized it for better locality and so on. Plus you are reducing the memory. If this allocation is happening inside a loop, then you are creating more and more garbage, which you want to avoid, especially in case of C++. In case of Java, well, since there is no question of delete or free, you are allowed to create garbage, and garbage collection is going to take care of that. So such issues we want to avoid, and that is where smart pointers come into picture, that as soon as, so for example in case of local variables, when you why local variables are useful is because as soon as you enter a scope or a function, that local variable is going to get instantiated, constructed, and then at the end of the function the destructor is automatically getting called, right. It would have been nice if this would have happened with pointers. where the allocation is happening via pointers at the start of the scope, and at the end of the scope automatically the destruction is happening. So this is where the smart pointers come into picture, where you need to overload essentially the arrow operator. So let us talk about that here, where that arrow might not be really defined for a particular type. So far what we have seen is that that arrow needs to be defined for a pointer, so A star P, then I can perform P arrow something. However, what I want to do is something different. So these are just some scenarios which I have illustrated where you can utilize these pointers, but what I want to achieve is A X and then X arrow something. This is what I want to achieve, where A is a class type rather than a pointer, as in this case. This is already supported by the language. This is now supported by operator overloading, right? However, A is user defined type, and therefore this arrow is not defined over A. So you need to explicitly overload this arrow operator. So let's take a particular scenario which is illustrated on slide number 29. So let's say that there is a roll number. So let me just, roll number CS17B010, right, indicates some BTech student from computer science admitted in 2017 in our CS17 class that we discussed a few minutes ago. Let's say there is this student, and this particular functionality is maintained as a class roll number, and that roll number supports a function called getYear. Now getYear is going to give you what is the year in which you were enrolled in this particular course, right. So a student has a roll number. So a student is a big class in which there is a small class object which is roll number, and this roll number, since that CS17B010 is a roll number, we need to get getYear defined on that. So CS17, so that 17 is essentially defining the year 2017. So what we want is that what is the year that a student was enrolled in. However, that getYear is not defined onto the student. getYear is defined onto the roll number, because essentially that is getting this information you are deriving from the roll number. Now one way of solving this mystery is that you can define another getYear onto the student. So there is a student getYear which internally calls roll number getYear, right. This is one way of solving the problem. However, it would be nice if I can take advantage, instead of redefining things, I would be happy if I can directly call getYear, which is defined on the roll number, onto the student, because the student is uniquely identified by the roll number, right. So it would be really nice if I can use getYear onto the student directly. So that is what I am saying when I say that an application may query a student, right, a student type, for knowing the enrollment year. So the student arrow getYear is something that the application wants to do. So as I was mentioning that you can implement student : getYear, and then internally it calls roll number arrow getYear, and however we can make the arrow smart. So let's understand that piece of code. So the main is essentially going to create a student which is going to say that, let's say the initialization is happening somewhere, right. So I am just going to call stud arrow getYear, and then some return or something, right. So there is a class student, there is a variable of that type, and I am calling getYear on that, where the student really so let's say that okay, so I should erase this part because this might be unnecessarily confusing. So the class student uses a private variable which is roll number, roll number, right. However, it does not have a function called getYear. If it has getYear function, then internally it can call r arrow getYear. So the class roll number essentially has a private variable string roll number. Do I have, or okay, so okay, this seems to have a public function which is get here. So I am not doing any parsing here of that roll number, but I am sure you will be able to realize that. So what I am returning is essentially only 2017. So this code works only for CH-17 or whatever XY-17, but you will be able to modify it accordingly, right. So there is a get here defined in roll number which is of this R variable inside this stud. So if I had done stud dot R arrow get here, then it is probably okay, but for that I will probably require this private to be changed to public and so on. So what I want to do is that this arrow should somehow be intelligent enough, so it should somehow be smart enough to change this. So currently or by default this is going to be arrow is being applied, okay, so let me just student operator arrow with argument as nothing, and on that we are applying the get here. So I am applying the arrow operator on the student, and then whatever it returns, to that I am applying the get here. So if I can do something like this, so in fact I should say this is also an arrow. So we can do some magic here such that this arrow operator is going to return instead the roll number. Then I am going to I can apply the language can apply the arrow operator which is defined for the roll number onto the get here as long as get here is a public function. So let us see if I can do that, and for that I need to overload the arrow operator inside the student class, and that should be public because main is calling it. So there is an operator arrow which I want to override, which takes no parameters, and what it should return is something such that I will be able to apply the arrow operator on it, right. So the language will automatically apply the arrow operator on that. This is the actual pointer related arrow operator. I mean, you can go deeper and return something on which the arrow operator is defined, on which another arrow operator is defined, and finally it calls the get here. For example, we were seeing that the plus operator over a class will amount to plus operator onto the string, which is also overloaded, which internally will call probably some other plus operator over an integer or something. So similarly here arrow operator might happen multiple times, so there might be a chain of invocations that can happen because of this, but we are talking about only one invocation. So this should return something of type roll number star. Since we are talking about the arrow, it should return roll number star. And how will it return roll number star is because what it needs to return is ampersand of R, which is the address of R, and then only it will become a pointer to R, and therefore you will be able to apply get here on that roll number because that is defined for the roll number class, right. So note that there is no get here inside the student, but we are able to apply get here onto the student. Internally the functionality is such that it will take care of converting this arrow onto the get here onto the roll number, right. So this is something which you can do using these smart pointers, and you can do other nice interesting things with smart pointers, for example the memory related operations that we have discussed and so on, right. Let me check if there are any questions at this stage. Okay, so there are actually lots of questions. We will take those up and then we will summarize. Alright, so there is a question from TKMKL here, can we return the value using pointer? So I don't know which slide you are referring to. Can we return the value using a pointer? So I didn't understand what you, I think this was asked on a particular slide. So if you can mention me the slide, I will be able to talk about it. So can we return the value using a pointer? Well, in general, of course, you can return a pointer, but you need to be careful about, so if in case this is talking about the subscript operator, whether I can return a pointer to that, no, you should not be doing that. So our code was like this, right. So we had CH-17 of 6 equal to something. If you return a pointer to the string, this is not the right type. This is pointer to string and the right hand side is string. So what you will need is essentially a star of this thing, right. That is allowed, that is okay. However, what we wanted is a syntax like this, and therefore you need a reference. In case that was your question, in case your question was something different, please clarify that. So this is from TKMKL. Question from PHGCT, beside code readability, are there any other advantages of using operator overloading, right. So as we have been discussing, essentially the primary reason why we have operator overloading is readability, right. You can do other things with it. For example, we have been discussing about, for example, smart pointers and operating overloading new and delete and so on, but really that is not something which will stop you from doing something, right. So if at all you want a custom memory allocation, you don't really need to get into new and delete. You can do custom memory allocation using some other functions of your own. So whatever you can do with operators, you can do with functions in general, and therefore there is really nothing which the operators are allowing you. It's mainly because you want to keep the functionality intact. The code should remain intact, the syntax should remain intact, but the functionality I want to change. For that, the operator overloading is really going to be useful. Alright, so that is another question. A question from BMSCE. Why is there a difference in the behavior of new operator when an array of objects is created in C++ and Java? Why is there a difference in the behavior of new operator when an array of objects is created in C++ and Java? So I didn't understand the question, what you mean by the difference between C++ and Java when a new operator is created for an array of objects. So you can create an array of objects using the new operator in C++ as well as Java, but I don't understand what you mean by the difference, right. So the new operator okay, so I should also clarify, this is not really related to the operator overloading per se, but in general when you are allocating an array and so on, you can as well use the new array operator subscript for allocating memory, and however that is not something which, so I don't remember if in Java you require such a syntax or a different syntax, and whether you are talking about this particular syntax in Java and C++ whether it is different, right. So that I am not sure, but if you have specific question exactly what you are talking about, please add it back to the question tab. TKMKL, can you say the difference between null pointer and a void pointer? Okay, so null pointer, okay, so let's, this is also not really related to operator overloading, but I will quickly mention. So a null pointer internally is pointing to 0L, the 0 long, where it's actually referring to some memory location which we are defining as 0 memory, the address is 0. When we are talking about a void pointer, that essentially is an opaque pointer which can point to any arbitrary memory location. So it can be int star, it can be char star, it can be some stud star, anything. So that void star is more like a handle which is given because we wanted to support, for example, malloc. Malloc needs to return a pointer to some type, right. So however, the type checking is not that much in C, and therefore what we needed to return was something which we could associate with any pointer type, right, because the left hand side might be char star, student star, or int star, float star, etc. But the right hand side malloc cannot change its return type based on the context. So in such cases, what helps if it returns void star, which can be assigned to any of type by typecasting, and as far as a void star pointer is concerned, it can point to any type, and then using typecasting we can get whether it is an integer or a character and so on, right. So void star can also be null pointer. For example, if a pointer is considered a void star ptr equal to null, right, that is also fine. So a void star pointer is essentially talking about an opaque pointer which can point to different arbitrary types. It just sequence of bytes that it is pointing to, or it can also be pointing to null. As far as null pointer is concerned, it's a specific value being stored inside a pointer of any type. So for example, all of these pointers can be null pointers. You can store 0 value there and it becomes a null pointer. Dereferencing a null pointer will result in memory error. Dereferencing a white star is disallowed in general. You need to typecast it to one of these types and then only you have to dereference. And why is that? Well, because there is no information with respect to how many bytes to access when I am accessing white star pointer, right. So when I say star p, I need to know how many bytes I am accessing. When I say that printf star p, if p is pointing to integer, I am likely to look at 4 bytes or 8 bytes if the integer type is 4 or 8. If p is pointing to a character, then star p should refer to a single byte. Or when p is pointing to a structure, it should return a sequence of bytes which is equivalent to the size of that struct. White star, there is no such thing as size of void, right, and therefore this is dereferencing a white star without typecasting should result in a compile time error. Dereferencing a null pointer should result in a runtime error. This is a question from CTEU. Can you give explanation of STL in brief and its applicability? So STL is as we all know, STL is a standard template library which is provided by C++. The advantage of this is that there are some existing, so whenever a language is created and you want to push that language to the masses, whatever are the usual functionalities that people require, you should be able to provide that as some kind of library functions, right. And therefore, for example, there is hash include string. If we do, then we have, or string.h, we already have functions which are inbuilt. If I asked you to write down your own string length functions, will you be able to write it? Yes, you just go over the string, look for /0 and you are able to perform that operation. However, if it is already provided by a library, it becomes easier for me to use that language. A similar concept is used as part of STL, where more of the collections or aggregates are already implemented as well as optimized for various situations inside C++. So what the standard template library is doing is that, let's say there are different kinds of collections. For example, a vector or a set or a hash table or let's say a list or a queue and so on. These are all different aggregates, they contain multiple objects. However, the objects might be of different types. For example, when I am talking about a list, I can add nodes to a list, but that as far as the list type is concerned, that is arbitrary. That can change depending upon the application. I might store an integer data item inside a node, or I might store 10 array elements inside each node. Right? So this is totally dependent on my application, but as far as linked list is concerned, it is still a linked list. As far as pushback to a vector is concerned, it is still a pushback. When I want to pop some element from a stack, it is still a pop. It doesn't matter which type the element is. Therefore, this STL, the collections need to be defined generically such that it should be applicable for all possible types, or almost all possible types, let me put it that way. Who will provide the type? Well, the application developer needs to provide the type. How will you specify the type when that collection is already defined? This requires the type to be passed as a parameter, and that is where templates come into picture. That you have a list class on which you can have all these operations, add a node, delete a node, add to the end, add to the front and so on. Let's say these are list related operations. These are going to remain independent of what exactly is contained inside a node. So that node type you can pass as a parameter to list, and then inside that the functionality remains the same. So when an application wants to use this list type, I pass it as a parameter which internally is going to use that particular type to implement those operations, to fill in those essentially gaps with the types. I am talking about list, but the same thing is possible with sets. I am talking about the operations on sets as far as union, intersection, etc. are concerned. Those are anyway going to be fixed for a particular set. It doesn't matter what elements are there in the set. So again, the templates allow us to pass that type as a parameter at compile time from the user, and that is where different collections are implemented as standard template library, right. So whenever we say list of int and then some variable name, essentially what we are passing in the angular brackets is essentially the type, the parameterized type to the template parameter, right. So using this STL, essentially our functionality, so you don't have to worry about, okay, is there a vector, do I need to implement a vector, do I need to increase its size when the array gets full. So all that is automatically internally handled whenever you do a pushback. That can be a good thing for readability, but then you should be careful that what you see is not what you get, which means that you might be doing pushback large number of times and internally the array is getting actually reallocated multiple number of times, which can affect your efficiency. So you should be careful while using all these automatized operations, right. Alright, so so that was a brief explanation of STL. Alright, so we'll continue with our discussion on the questions that you have posed. There is a question from BMSCE. Is there any way with which the memory freed by garbage collector be taken back? So I don't know what you are talking about, reason being that we are talking about C++, in which case there is no garbage collector, but if you are talking in the context of Java, whether the memory that is freed by the garbage collector, can you get it back? So I don't know of any standard way of doing this. To the extent I know that the garbage collector, whatever memory it has reclaimed back, well, that is there with the garbage collector as a free memory. So I don't think that without any allocation again, whether you will be able to get it in a standard way. If there are any hacks, I am not aware of those, but as far as standard mechanism is concerned, that is something which you can do, that you can allocate memory again and get that memory. Then as far as, okay, so there is a question from CTEU, what is the difference between a containership and inheritance? Okay, so I don't know how it is related to operator overloading, although I don't know what is meant by containership really. Inheritance, I can tell you that it's essentially talking about that there is a base class, and if you want to specialization or extension of the properties that are given by the base class, then you can have inheritance to have derived classes. I don't know what exactly you mean by containership. Is it like encapsulation or something else, or whether one is contained into other? If that is what you are saying, essentially that means that, for example, in our case we had student as the class and inside that we had roll number as another class, right. So if that is the containership that you are talking about, definitely that is very different from the derivation that we are doing, that from the base class properties we are inheriting the properties in the derived class and extending the functionality. Whereas in case of one class being inside the other, I mean, there is hardly any correlationship between the properties of the two. These two can be totally independent as far as their properties go. BMSC, previous question elaborated. The new operator, when used with an array of objects in C++, allocates the entire memory required for all objects, but in Java it creates an array of references. Correct. We need to allocate memory for every object again with another. That is correct. So yeah, so there is this is a good observation, but you need to observe slightly more precisely. So what I would, okay, so let me just mention that briefly here. We have in Java is that if you want to allocate this array, then each of these is a reference, right, and therefore that needs a separate allocation again, right. So there is a new required for the array, and then there is another new required for each of these. This is what the question is being asked. This is what is there in Java, whereas what it is saying is that if you have in C++ an array, well, that is just sufficient if you do a new. No, that is not sufficient. Reason being that if you have this as all integers, for example, then you need only a single new. However, if all of these are pointers to something, then you need a separate allocation for each of these, right. It is not automatic. So when you are talking about, when you are comparing references, you should compare reference against pointers, and that mechanism remains the same in both Java and C++. When we are talking about these as basic elements, let us say structure elements or integers, characters, at that time new is sufficient. Here also at that time new is going to be sufficient. You are not going to create objects. Here you are, if you have an array of directly the objects, that is sufficient, but his object is essentially the whole memory for that object. Here if you are creating an array of references, Well, you should compare with array of pointers, and if you have array of pointers, well, you are going to require that for loop to go over each element to create the each allocation separately anyway, right? Okay, that was a good question. CTEU, can we allocate and initialize an array at the same time using the new operator? So the question here is that can you allocate using new, for example, for example int star x equal to new int, and then can you initialize it somewhere, right? So I don't know if there is any such syntax where you can initialize it directly. I'll have to check, but I don't know of any such syntax where the initialization can happen exactly along with the new int something, right? So, but one way of doing it is that if you have this as a class, right, and then you are having new a, you might be able to specify initialization parameters to a such that an appropriate constructor gets called, right? So that is possible to be done, which internally will do the initialization, because the constructor can have arbitrary statement. That is possible to be done, but using an equal to for an array, that I don't know if that is possible to be done in C++. My feeling is it should not be, because you cannot have multiple equal tos, but yeah, I am not aware about any such way of doing. This is a question from PCE. What is memory leak and how can we trace memory leak while overloading new and delete? Okay, so let's explain what is meant by memory leak. Memory leak essentially means that you have created some memory and you were possibly going to use it, but now you have somehow lost track of that pointer, right, pointer to that memory. So which means that that memory is allocated, right? The memory allocator, let's say the heap allocator or something, yesterday we were discussing about that best fit, first fit, etc. That says that this memory is allocated, but then you have lost reference to it and therefore that memory is unusable. This portion or this way of allocating memory and losing track of it is called as memory leak, right? So when we say that this particular aspect of the code or this particular function has a memory leak, it essentially means that it has generated some memory, it has used some memory, but you have lost track of it, right? And how do we trace it while overloading new and delete? So in general, I mean, it has nothing to do with overloading new and delete. In general, whenever you are allocating memory, whether you have created memory leak or not, this goes back to the what garbage collectors do. Essentially what is required is that from every pointer that you have accessible in your program, let's say there are 3 pointers P1, P2, P3, we need to start from there and go on traversing all possible memory locations and pointers within them to find out if there is, to mark whatever is possible to be reached. So let's say there is some pointer P1, some pointer P2, some pointer P3. It is pointing to some memory region, right? And then there are some pointers here which are pointing to some other memory location, and then there is some pointer here which is pointing to some other memory location. There is another pointer here which is pointing to some other memory location, and then there is this memory area. Maybe this pointer is pointing back here, this memory area is pointing to this again, and then maybe this pointer is pointing somewhere else, and so on, and P3 is, let's say, null, right? There is some complex structure of memory allocation that we have used, and that is the current state, right? And the overall memories, well, there are other allocations that have happened somewhere, alright. So this is currently the allocated memory, and then there is a free pool which is maintained somewhere, right? So this is free, which the memory allocator is maintaining, right? So whenever you allocate, whenever you invoke new or malloc, you are going to get memory from these blocks. So now let's look at this part. So these P1, P2, P3 are the only pointers that are currently live or the currently accessible. What is done is that you start from there and start marking the memory. So let's say that P1 is of this type, so I am going to mark all of this memory area, right? Mark meaning not there, but somewhere in the representation. Then I am going to traverse all the pointers which are going to be inside, which are going to be accessible from there. So I am going to mark this area, I am going to mark this area. From here there is some memory, so let us say this is dangling pointer, so I am not going to mark anything, or maybe I will mark it also, which is a dangling pointer. And then from here I have this as the area that is already there, and then this area and so on. Then I go to P2 and start from there, so maybe I will go on marking, these are already marked and so on. Finally I have all of this marked. Part is something which is reachable from the current set of pointers I have, and therefore this area is not a memory leak. The memory leak is that the remaining portion of the allocated space, which is this part, so let me mark it as something like this. So the remaining part of the allocated area which you have not really marked during the traversal, that becomes the part of the memory leak. So the garbage collection is essentially going to track these out, and since there are no pointers coming here, you cannot refer to these via your program variables, and therefore this gets added to the free list from here, and now this becomes a free list. So now your free area is increased and this becomes your allocated area, right. So that is one way of doing, although this is something which you need to do as part of separately. Either you have to do it manually if there is a memory leak, alternatively there might be some tools which will track your what are the current set of pointers that are active, and from there go on tracing separately. You just don't go and mark it because these are values. You need to create a representation of that into another memory part and create it. Essentially you need to do what is called as mark and sweep algorithm, right. So this is a standard algorithm for garbage collection where you go on marking and then sweeping into the memory. So you go over memory, whatever areas are marked that I am going to ignore, whatever is unmarked that I am going to reclaim as the free memory, right. So that is one way of handling the memory leak. But note that this has nothing to do specifically with new and delete. This is something which you will have to do on your own, either as a separate functionality or as a manual process. Is there any operator which will be overloaded default by the compiler? This is a question from BEC. Well, okay, so that's let me put it this way. As far as the standard template library is concerned, it is also designed by users, right. It's not something which is part of the language. It's not part of language specification. Like the programmers like us, just that the designers of C++ only came up with the STL, and therefore we say that it's part of the standard template library. But essentially that is also an overloading which is done by the user. So for example, tomorrow I develop or you develop your own library and it becomes standard, many people start using it and so on, you might want to push it into the standard, and if the standards committee agree, then that will become part of the standard, but this will still be done by the user. Similarly, all those plus operator for string and plus operator for subscript operator for vector, etc., these are all overloaded operators by the standard. As far as the language is concerned, language doesn't really overload an operator as such. However, if you go very technical, you can say that actually, coming to look at it, when I am talking about int plus int or float plus int or float plus float or double plus int and so on, double plus char, etc., it's actually the same plus operation which is happening on a basic type. There is an automatic conversion that is happening. Let's say float plus int will convert this integer into a float internally and then take the summation, right, because the floating point bit pattern is going to be very different from the integer bit pattern, and the plus operation will be defined on the floating point separately and integer separately. So there is an internal conversion happening by the language itself, not really the language, but the code is going to get generated accordingly, that there is a conversion happening, automatic typecasting happening, also called as coercion. So this, if you look at it at the language level, it actually supports multiple types, and appropriate plus is going to get invoked automatically. So to be very, very technical, you might say that there is operator overloading happening at this level, and not only in C++ or Java, sorry, not only C++, but also in C in some sense, right, because this is supported in C. But that is not what we call as operator overloading really. We call it more for the user defined classes, right, and therefore it's we should not say that it is actually supported by the standards supported inside the language itself. This is a question from PSGCT. What are the errors that could occur when combining compile time and runtime polymorphism, like having a virtual operator overloading function and so on? So it's possible. So for example, like whatever, this is not again specific to operator overloading, but in general whenever you have virtual functions, and so what can happen is that the base class pointer might point to the derived class object or some such thing, right. So you have the base class, from there is a, sorry I should draw it in the opposite direction, then there is a D2 which is deriving from D1 and so on. Now you have a base class pointer, let us say something, and then if some condition, then b equal to new base, else b equal to new, let us say D1. Now this condition in general can be runtime dependent, right, and therefore we do not know what b is pointing to at the end of this if else block. Now if I say that after this statement I am calling b arrow fun, which b arrow f I am calling, that I really do not know, reason being that b might be pointing to the base class or the derived class. This information is available only at runtime, which means that if I am invoking a pointer, invoking an operator or a function which is defined for a base class but not for, or maybe the other way around, which is defined for the derived class but not at the base class, and the pointer is pointing to the base class, then that should result in a runtime error. I won't be able to figure that out from the compile time because I don't know if b is really pointing to the base class or the derived class, right. So whatever is possible, so for example that function might be available only in the derived class, not in the base class. However, there should not result into a runtime error if b is actually pointing to the derived class always. A similar thing is possible when we are talking about operators being overloaded for the derived classes but not for the base classes. In such cases, well, you want that there should be a runtime error that should get invoked if the pointer is pointing to the base class and therefore the operator is being invoked for the base class which is not even defined, right. So this cannot be identified at compile time. Whereas there are some things which are possible to be identified at compile time. For example, if this C is not really coming out of runtime information, right, there, let us say this is not a scanf ampersand of C or C in C. In such cases you will be able to figure out, let us say this is C equal to, in such cases you know that B is actually, the compiler knows that B is not pointing to the base but it is pointing to the derived, and therefore B arrow F should be pointing to the derived. In such cases you will be able to, the compiler will be able to make identify errors more systematically at the compile time because it has more information about the program values and so on. However, in general you cannot have that, and therefore some things have to be pushed to the runtime, some error checking has to be pushed at runtime. Good, that was a good question. CTEU, well, consider the following, okay, so that appears later, okay. So this is an example code. So int I j star p star q I equal to 20, p equal to ampersand of j and j equal to 2 into star p. Is this operator overloading for star? So the, okay, so let me write down the question here in case you are not able to see that. So we are saying that int ij and then star p star q, I suppose, yeah, and then I equal to 20, p equal to ampersand of j, this j or I, j, and then j equal to 2 into star p. And then the question is this an operator overloading for star, right? So whether this star and this star, okay, let us try to figure out what is happening in this case. So what we are saying is that if we have overloaded the star operator which takes integer as a parameter, so this cannot be done on a class because 2 is not really a class variable or an object. So this has to be defined outside the class. So if the binary operator star multiplication is defined with 2 as the first argument, that is integer as the first argument, and star p which is integer as the second argument, then this can invoke the particular operator, right, that is okay. As far as dereferencing of p is concerned, we will have to overload the dereference operator which has p However, in this case this is not really going to affect because this P is again a basic type, right. So we won't have any dereferencing being done for the basic type. So the only possible overloading that is possible is this star, which is a multiplication operator rather than the star operator, right. But if you have anything further to that, please ask. For example, can it happen that if P is a class type, can you have the star operator do something about it, right? That seems to be possible, but then star operator has to be defined for this particular P's type, and then whatever it returns, but that's a unary operator, right? So it's a unary operator which is defined, which is going to return something, which might be likely to be a numeric type, and this star is going to be a multiplication. So integer multiplied by whatever it returns, that should happen. So there will be two operator overloading required for that. Okay, so that is a question from CTEU. Alright, so that ends the questions that have been asked, and we have close to half an hour to go over some of the questions from the quiz. Right, so I am not going to take up all the questions. I would strongly recommend that you guys try this quiz. In fact, some of you might have already tried in case it is available. So I am going to discuss a few of these because not all of these I'll be able to write on the board and so on. Some of these are slightly longer. So I'll take some of the questions here. So the question is that unary operator is to be overloaded, right? And X and Y are two programmers, right? X overloads the unary operator using the member function, and Y overloads using the friend function. Okay, let me read it again. A unary operator needs to be overloaded. The programmer X overloads it using the member function, and programmer Y overloads it using the friend function. Now what are the statements that are true? The first statement is access technique, programmer access technique, which uses the member function, does not take any explicit arguments and return no explicit values. Right? Is this correct? And then yeah, so there is a user hand raise. I'll take that up as soon as I finish some of these questions. Second is access technique takes one reference argument, right? So which of these is going to be true, first and second, that we have to see. So since it's a unary operator, although it is not mentioned, and it is mentioned that it is a member function, there is an implicit argument which is already passed, and therefore the unary operator, since it takes one argument and that is implicit, that means that access technique should not use any explicit argument. There should be zero explicit argument. So the first answer is correct. Now there are another two parts to it. Whilst technique, which is overloading using the friend function, it does not take any explicit arguments and returns no explicit value, right? And the second is whilst technique takes one reference argument. So again in this case, since whilst technique is not using member functions, it's a function which is it's an operator being overloaded outside the class, therefore it should have explicitly the operand that it requires, and therefore whilst technique will take the one reference argument. So these two are correct. Another question is how can we disallow or how can we restrict dynamic allocation of objects of a class using new. So there is a class, let's say a student, and I want that a programmer should be able to do student XYZ, but you should not be able to do student star X equal to new student, right? So that is something which I want to disallow. So how can this be done? And there are lots of there are four options given here. By overloading the new operator, that is one. Second one is by making an empty private new operator. Third one is by making an empty private new and new arrow operators. And the fourth one is by overloading new operator and new array operator, right? So which one of these is correct? The third one is correct, that it should be a private new and new arrow operators, and it should be empty, which means that you are not really doing anything in that. And why you are making it private? So that the world will not be able to use new over those objects. Which of the following sentences are true? Compiler creates a default copy constructor for every class, whether this is true. Compiler creates a default assignment operator for every class. So which of these turn out to be true, that you have to answer. In this case the answer is that yes, both of these are essentially going to create, essentially going to get created, the default assignment and the default constructor, unless you specify like explicit and so on in your arguments. Another question is, what is the correct syntax to overload equal to operator for a class, right? So there are four options. Let's say the class name is test, and whether operator void operator equal to with two arguments test comma test, whether this is correct. Void operator equal to with a single argument const test ampersand, which is a reference argument. Third one is void operator equal to with const test star, a pointer to test. And the fourth one is void operator equal to with test as a single parameter. So essentially what turns out is that since the right hand side something equal to something, the right hand side is only a copy, therefore you should pass a reference to and a const to that particular type, and therefore the second void operator equal to with const t ampersand as the correct type. Alright, so which of the following operators cannot be overloaded? Scope resolution operator, size of, type ID, all of the above. The answer should be all of the above, none of these can be overloaded. How many arguments are required while overloading binary operators using member function? This is similar to the first question that we discussed. So binary operator using member function will require one less, and therefore it requires one number of arguments, right? So these are a few questions that I wanted to discuss from the quiz, and there is a hand raise, so let me take that up. This is a question from SVEC. Yes, please ask the question. Yes, please ask the question.
Sir, can we overload an overloaded operator?
The question here is, can we overload an overloaded operator, right? So what this is asking is that can you have multiple ways in which you can overload this, right? So when you have, let's say, plus operator overloaded for doing something, can you still have another plus which is doing something else, right? For example, if the plus operator is taking some class with some parameter int, can you have some other class or the same class with parameter string, for example? What do you think? Is it going to be possible or not with whatever we have looked at? SVEC?
Yes, sir.
Okay, good. So that means we were paying close attention to what we did. So in one of the examples what we had was the plus operator was getting defined twice, once for, let's say, int plus class, and another was for class plus int, right? So in such cases you might be required to do operator overloading multiple times, and therefore an operator which is already overloaded, you can still overload it to change the functionality by changing either the number of parameters or by changing the type of the parameter. Is that okay?
Thank you, sir.
Okay, thank you very much. Okay, so that completes the questions that are coming here, and we still have some time, but let me try to wrap up whatever we have studied so far in the remaining time, and if there are any further questions we can take those up after this summary. So what we saw is that some languages such as C++ do allow overloading operators, and the primary reason why this is needed is not really that you can get some additional functionality. If there would have been some additional functionality which you can get, then it's likely that Java would have supported it or some other language would have supported it, right? Whatever you can do with operators, you can do the same functionality wise via different function calls. And however, operators sometimes are very intuitive to look at. When we say that students of subscript, that does mean that we are referring to a particular student into that students class. So such flexibility is very nicely modeled using operator overloading, and C++ is a language which allows us to overload these operators. And some of the very interesting things what we have looked at are only the basics, but as you program more and you try to overload other operators, you will realize that an interplay of, let's say, operator overloading plus inheritance plus templates, etc., when you combine them together, you might be able to perform some beautiful things in the code over what an individual template or individual inheritance or individually operator overloading allows. And because of this, the code will turn out to be will start looking much more easier to read and easier for you to even sometimes debug, right. So when you start understanding the code better, it becomes easier for you to debug it out as well. So some people say that, for example, on WordPress, code is poetry, right. Some people say that code should be viewed as a piece of art rather than a scientific method and so on. So the reason why all of these people say is that there requires a lot of hard work to write the code in an elegant manner, and if you use operators or operator overloading judiciously, you will be able to convert your code such that it becomes very nice to look at as well as to understand. And what we have studied in last 5 hours is essentially an entry into the world of operator overloading, where you will be able to apply the syntax that we have studied and some of the concepts that I could mention to create better programs than what you were already creating. At the same time, I should add that cautionary note that you should not get into a very arbitrary kind of operator overloading. For example, there was a question that can I do multiplication inside a plus operator, right? Yes, you can do that. Unfortunately, C++ compiler will not stop you from doing it, right? So there should be a logical connection between what you are, the operator that you are overloading, and what its intended meaning is, right? Because the premise that we are starting with is that the operators are going to increase or improve the readability of the code, which is likely to be very useful when you leave your job and somebody else takes your code and looks at it. He should not probably start cursing you, right, even though he might not know you, but he should probably start appreciating, wow, that's a beautiful code that you have written, and somewhere you feel yourself very nice when you have written down a piece of code that looks good, compiles well, and executes exactly the way you had intended, right. So for your own satisfaction, sometimes it's useful to write good codes. So from that perspective, we looked at polymorphism as the basic aspect of overloading, in the sense that the meaning of the same mnemonic might be different depending upon the context. In that, we looked at both function as well as operator overloading, and as we discussed, function overloading is supported in multiple languages such as C++ and Java, whereas operator overloading is supported only in C++ and not in Java. And then we looked at some of the rules, for example, the arity, the associativity, the precedence, etc., that cannot change for an existing operator. There are probably technical reasons for this, because the parsing is essentially going to take care of all these precedence, operator overloading, etc., where it does not know anything about if the operator is overloaded or not, right, at the parsing level. Whereas these what is the type of a particular argument and which function to call, all of that happens at the semantic analysis level, which is going to come much later than the syntax analysis phase. Therefore, these rules have to be strictly enforced as far as syntax is concerned, and therefore you can play around only with types but not with the arity and associativity and precedence, which gets enforced by the syntax analysis phase. Then we also looked at what operators cannot be overloaded and what operators can be overloaded. And we also looked at some of the basic ways in which simple operators can be overloaded, like plus, minus, star, etc. Then we started looking at unary, binary operators, and we realized that the left shift operator can be considered as a binary operator, and if you want it to be doing multiplication or the left shift by 2, or left shift or multiplication by a power of 2, then that is something which you can implement using operator overloading. But then we realize that in case of cin and cout also, we have these left shift and right shift operators which are used for input output purposes. So I should be able to say cout and a variable of my type, but that is not something which is very trivial, in the sense that we cannot really go and change O stream or I stream. So therefore we looked at overloading operators outside the class, and those operator overloading outside the class led us to talking about public functions, which if you have available, then those will be able to help us implement the functionality of that operator. However, in cases where that public is the information that you want is not publicly available, then you need to define it as a friend class, friend function inside the class whose private information you want to access. And then we overloaded the C in C out operators, so the right shift and left shift operators. We looked at how to overload new and delete, and internally, I mean, as an example we just took that internally it is using malloc and free. However, you can do arbitrary processing using new and delete. In fact, any other operators that you have that we have overloaded, what we have given are very simple examples just for the sake of explaining the concept. However, if you understand the concept well, you will be able to apply it for more complicated versions, right? And if you have any questions in complicating your program with multiple operators and so on, please feel free to get in touch with me on the forum. Then we have array subscript operator overloading, as we discussed CH-17 of 6, and towards that there was a small difficulty with respect to what it should return. It should not return a copy, it should return actually a reference to the variable, reason being that subscript operator can be used both as on the R value side, on the right hand side of equal to, as well as on the left hand side of equal to. So if you just return non-reference, a copy, then the R value will work, but the L value will have issues. Whereas if you set a reference, then either way it should be okay. Finally, we looked at how to overload the arrow operator, and we saw that that get year function was not defined for the student, but internally I could overload the arrow operator and change that student into a roll number. So I return the roll number, and internally then I can call the arrow operator over the roll number. So these are some very interesting things, and because some things are happening magically here, because when we looked at stud arrow get here, we thought that stud arrow get here should have arrow operator being defined on student. That is something which we will mentally think about, but that will not something which will happen. Therefore, we need to be careful when we are overloading operators, because what you see is not what you get when you have operator overloading. So you should not get swayed away by, okay, I can do magical things with operator overloading, let me be ambitious and I will overload it in this manner and that manner and so on. You can do that within limits as long as it's logically coherent to what programming you want to do. Right, so we complete our discussion on this. There are a few backup slides which I will probably skip. Let me look at if there are any questions. So there is a question from BMSCE. So any specific reason for not including pointer concepts in Java? So this is not this is a more like a design decision. It's not that there are no pointers in Java. I mean, all your references are essentially pointers. However, what this means is Java wanted to get rid of some of the intricacies that C, C++ have with respect to pointers, and in general there are lots of students who don't like pointers. There are lots of programmers who avoid pointers as much as possible, only as much is required that should be done and so on. The problem comes mainly because of the address of, you are able to take address of a particular variable. Using pointers or references is not really a problem, but then the issues, the memory issues that come up with it are really huge, and Java designers wanted to get rid of those. So two things that they did was they disallowed taking address of a variable first. Second thing, they disallowed freeing memory. So the programmer should not worry about deallocating memory, right? You can allocate memory, that is okay, but deallocating can be left to the garbage collector. So therefore they came up with this garbage collection mechanism in Java. However, we should also appreciate and understand what was the motive behind supporting pointers in early languages such as C, C++. C++ was probably just a follow-up of C. So the reason was that C was a compact language, right? At that time the memory sizes were small, the operating system they wanted to create should be efficient, and therefore they wanted more efficient mechanisms of, let's say, passing variables. You don't want to pass the whole array. Instead, you should be able to pass only the the address of the array and be done with it, or you don't want to pass the whole structure, can you pass just a reference to it and so on. So that is where the pointers were created, and if used properly, definitely pointers are very useful, and those are used in many large scale applications also. However, it has its own downsides which are probably were planned to getting removed from Java design, and therefore they disallowed the usage of address taking. But as far as pointers are concerned, those are just appearing in different form as part of references, but the pointers are definitely there. And let me see if there is anything interesting in the backup slide that I would like to highlight. So there is an overloading versus overriding on slide number 33 that I have. This we discussed, but you might want to go through it offline. There is pointer to member operator which is disallowed to be supported, but what that means, that is something which I have given on slide number 34. And then there are a few things about function overloading that I have mentioned related to the base class and the derived class on the further few slides. For example, what happens when you do not have virtual. So for example, on this example on slide number 36, we expect that the output of left hand side code should be in A and the output of the right hand side code should be in B, because we are doing new B here, and then when I call A arrow fun in main, it should actually call B arrow fun rather than A arrow fun, right. So therefore we expect it to be in B, however that does not happen. In fact it prints in A, and the reason is given on slide number 37, that we are missing virtual from the implementation of fun, and therefore that base class pointer essentially calls only the base class version. When you want base class version to point to the derived class object, I mean pointing is okay, but also invoke the functions of the derived class. At that time you need to have virtual functions. So that is what I have discussed on slides 35, 36 and 37. And why is this useful is because you might have a base class like shape, from which you can have further derivations, for example ellipse, circle and circle origin, circle at the origin and so on. And then I have shape C equal to new circle origin, and then I just do C arrow draw. Now C is of type shape, right. So this should not be shape, this should be shape star C equal to new circle origin, and then C arrow draw should just take care of drawing whether it is a circle at origin, whether it is a circle, whether it is an ellipse and so on, right. So that should automatically happen depending upon the type it is pointing to, although it is a base class pointer. Right. So this is something which the virtual functions along with inheritance gives us, and you can actually have a generalization of that. You can have an array of shape star. Some of the elements of that array could be circles, some of them might be ellipses, some of them might be circles at the origin, some of them actually might be squares and triangles and so on, right, all of them derived from shape. And then you just in a loop or using an iterator, you just go over the complete array or a vector and you invoke draw on each of these pointers, each of these pointers to different objects, and appropriate draw method should get invoked depending upon the type it is pointing to. This is really a magical thing which is supported because of the virtual functions and inheritance, right. The base class pointer, depending upon the type, is invoking appropriate function in different iterations, right. So this is a very nice functionality for the programmer, and used judiciously this can really be a boon while programming. Right, so that is what I have explained on slide number 38. Then slide number 39 etc. is really talking about the abstract classes and virtual functions, interface etc. That I will skip. So we will stop here, and thank you for all your questions and your attention, and thank you to QEEE, Professor Ashok Jhunjhunwala, Lavana for coordinating all of this, all the technicians here for sitting here listening to whatever I am talking, and taking care of all these technical issues and so on. So thanks a lot, and hope you have an enjoyable C++ experience, as well as you learn something about operator overloading. I hope you will be able to learn more in your classes in the local college. But if you have any questions, please feel free to post on forum or get in touch with me, not a problem. Okay, see you, bye.